Hello, my dear friends. You are together with Teacher Jerome, a teacher of mathematics and physics. Today, also, we are going to make some demonstrations on the physical properties of light. Today's demonstration is based on refraction of light on curved mirrors. Uh, Last time we have seen reflection of light on the plane mirror. Now let us see how the light reflects on curved mirrors. This simulation is based on the concept in similar to a reflection of light through the curved mirrors. So please follow keenly this simulation and you are going to see how it is very understandable and very interactive. I submit you to use Colorado PHET Simulation to do different simulations in different concepts, especially in physics. Now make sure that you do have enough connection and well conducive environment to do this simulation. PHET means physics, education, technology. Now let us browse. Good. Next time we shall see the refraction of light through the optical lenses, but now we are going to see on the curved mirrors. We normally have two kinds of curved mirrors. We have concave mirror, like this one, and also we do have convex mirror. The concave mirror, it is a kind of curved mirror which has the reflective surface which lies inward of the curvature. That is the concave mirror. It is a kind of curved mirror which has a reflective surface rise inward. While the convex mirror, its reflective surface lies outward of the curvature. Now, in order to see or to draw the image by representing different position of the object, we have to draw the three principal rays. We use three principal rays. We do have different kinds of rays. There's marginal rays, principal rays, main rays. So here we can use the principal rays. There are three principal rays. The first ray, the first principal ray, it is the incidence ray from the object which reflect passing through the focal point. The incidence ray from the object parallel to the principal axis reflect passing through the focal point. That's the first ray. The second ray, it is the incidence ray from the object passing through the focal point will reflect parallel to the principal axis. Incidence ray passing through the focal point reflect parallel to the principal axis. That's the second ray. The third ray, the ray which is passing through the center of curvature, reflect passing through itself. Or in other words, it is undifracted. Those are the three principal rays that we normally use to draw or to create the image of the object. And remember, the curved mirrors has different parts. We do have the principal axis. This is a horizontal line or the line of symmetry which cuts the mirror into two equal parts. This horizontal line, that is called the principal axis. We do have the center of curvature, the center of sphere at which the mirror is thrust, So the mirror, it is somehow this sphere. When you slice it, get this curved mirror. So the center of that curvature is called the center of curvature. Now, the point midway between the center of curvature and the mirror, the point midway between the center of curvature and the vertex of the mirror is called the focal point. Focal point. The point in the midway between the center of curvature and the vertex of the mirror. Focal point. The distance between the vertex of the mirror and the focal point is called the focal length. Those are the key concepts you have to recognize in the curved mirrors. Now, let us see the image formation due to the different position of the object on the concave mirror. Now, let us use a start to use arrow to make it very clearly. We do have different cases where you can locate the object to get different characteristics of the image. Depending on the position of object, you will get a certain nature of image. This is what you are going to see. Now, first case, when the object is beyond the center of curvature. In other words, is beyond the 2F. If the distance from the vertex to the focal point is F, and this focal point is a midway between the center of curvature and the vertex, so the distance from vertex to the center of curvature is 2F. So the first case, object is beyond 2F or beyond the center of curvature. If the object is beyond the center of curvature, then the image that will be formed between center of curvature and the focal point. It will be formed between center of curvature and the focal point. The image is real because it is formed by the intersecting of the real rays. It is real. It is diminished or smaller than the object in size, diminished. And it is inverted, you can see. The image is inverted. And that's what you can see when you put the object beyond the center of curvature. The image that will be formed will be real, smaller than object, diminished between the center of curvature and the focal point. Those are the characteristics of the image that will be formed. The second case, when the object is located at the center of curvature, or standing on the center of curvature, or standing on the 2F. Now, what about the nature of the image? On the center of curvature, it is lastly here. If the object is located on the center of curvature, the image that will be formed also on the center of curvature. If the object is standing on the center of curvature, the image will be also on the center of curvature, in the same position. The characteristics of the image will be on the center of curvature. Image will be on the center of curvature. The same size as the object. You can see the image and object, they have the same size. Will be real and inverted. So those are the characteristics of the image when the object is located at the center of curvature. Image has the same size as the object. Image is inverted. Image is real and located at the center of curvature. That is the second case. The third case, when the object is between the center of curvature and the focal point. When the object is between the center of curvature and the focal point. If the object is between the center of curvature and the focal point, the image that will be formed beyond the center of curvature. So image will be formed beyond the center of curvature. Those are the characteristics of the image. Be formed beyond the center of curvature. The image that will be formed will be magnified. Image is formed beyond the center of curvature. It's magnified. And also it is a real image. That's a real image. And also this image, it is inverted, you can see. Image is inverted, magnified, real, and beyond the center of curvature. That's the characteristics of the image that will be formed where the object is between center of curvature and the focal point. So this is the third case. The fourth case, when the object is standing on the focal point. When the object is standing on the focal point, this is the fourth case. When the object is standing on the focal point, the image that will be formed at infinity. Absolutely. Image will be formed at infinity because the ray will never intersect. So it is just assumed to be at infinity. That is where I can find the image. Now, the fifth case, what if the object is between the focal point and the vertex? Object is between the focal point and the vertex. The image that will be formed behind the mirror. You can see. And this image, it is virtual. This is a virtual image, which is formed by the intersection of the virtual rays or the prolonged rays. So this is a virtual image. This image is magnified. You can see the image is bigger than the object. That is magnified. And this image that is virtual and applied. So these are different cases of object position where you can get different kinds of the image for the concave mirror. Now let us see when you have the convex mirror. For the convex mirror, what you normally has, wherever you can press the object, the image that will be formed behind the mirror. Image will be formed behind the mirror, smaller than the object, you can see, and which is applied. The characteristic of the image that is formed on the convex mirror, image is applied, smaller than the object or diminished, and which is also virtual and applied. Image is applied, diminished, virtual behind the mirror. Always, wherever you can place the object, the image will have those characteristics: applied, diminished, virtual behind the mirror. So those are the characteristics of the image that will be formed. Now, these are the ways that you can use to locate the object to get different kinds of the image. So we draw three principal rays. You should remember the first ray, which is parallel to the principal axis, will reflect passing through the focal point. The second ray, the incidence ray passing through the focal point, will reflect parallel to the principal axis, and the last ray, a ray passing through the center of curvature, passing through itself. These curved mirrors have different ranges of application. They are used for the headlights, car headlights, and some that are used as car rear view, and they are used in the hospital and in different fields. So curved mirrors are normally used. So thank you so much to follow these simulations. You can visit PHET to blur or to make this demonstration, and it is very clearly and very understandable to the students if you use Colorado PHET simulation. So see you next for the next simulation regarding on the lens or the refraction of light through the optical lens. Thank you so much.